Hi dear student, this is Wajid Ali Shah and I welcome you back to the video session of Wheatstone Bridge, which is given on page number 98 of class 2nd year book. This bridge was first proposed by the Wheatstone, an English telegraph engineer, for measuring accurately the value of the unknown resistance. The construction of the Wheatstone Bridge is given here. For example, 4 resistances are connected like this. This is resistance P, this is Q, this is R, and this is the unknown resistance X. A galvanometer is inserted like a bridge between the resistances, and a battery is connected like this. This is high potential, this is low potential. So looking at the diagram, we can see that the current is flowing clockwise through the circuit. For example, the total current I, it is moving up. Reaching at this junction, the current is divided in I1 and I2, like this. When the same current approaches this junction, again this current I1 is divided. One part of the current is moving down through the galvanometer, another part of the current is passing through the resistance Q. Again, when this current I2 is passing through R, it approaches this junction, some part of the current is flowing through the galvanometer in upward direction, and the remaining part goes through X, I2. The working principle of this Wheatstone Bridge is basically null point. What is a null point? Null point is that point at which the deflection of the galvanometer is 0. How we can say deflection of the galvanometer is 0? Even if we can see that the currents are passing through the galvanometer. So it happens only in this condition that the magnitude of the current moving up is equal to the magnitude of the current moving down. So the net effect of the current through the galvanometer is 0, and galvanometer shows 0 deflection. So that point is called null point. Null point is that point where there is no deflection shown by the galvanometer, even the currents are passing through the galvanometer. So when this stage happens, we can write I1P is equal to I2R. Simply we can see that these two resistances, the potential drop of this resistance is equal to potential drop of this resistance, as their potential differences are equal. So their potential drops again must be equal. Similarly, the potential drop of this resistance I1Q should be equal to the potential drop of this resistance. So we can write I1Q is equal to I2X. This is equation 1, this is equation 2. And all this happens at null point. So, because of this null point, we can find these equations. Dividing equation 1 by equation 2. We can see that I1P divided by I1Q is equal to I2R divided by I2X. Cancelling I1, I1, I2, I2, we can have a relation like P over Q is equal to R over X. From this equation, finally we can have an equation like X is equal to QR divided by P. So this is a relation which is basically used to find the value of the unknown resistance X. In this experiment, we must know the values of Q, R and P. Means if we know the values of P, Q, R, we can find the value of X by the use of Wheatstone Bridge. Thanks and have a nice day.